Hi everybody, welcome to another video in pre-calculus section 9.3, the ellipse. So an ellipse is the collection of all the points in the plane, the sum of whose distance from two fixed points, the foci is a constant. So now we have not only one focus but two, the plural focus is foci, so we have two foci. And if we want to draw an ellipse, we have two fixed points, the foci, and then we have a string, a loop of string around it, and put a pencil and push the string, and then when we rotate, when we go around, as long as the string, the point on the string and the two foci form a perfect triangle, meaning that we will not have any lag on the string. In that case, we can have an ellipse. So if we on the parabola we have vertex, focus, and directrix, in the ellipse there will be quite a few more characteristics. So the center obviously is at the center. There will be two foci, and the 2 points on opposite and on the same direction as the foci. The foci are the vertex. So we have two vertices, two foci, one center, all of which on the same line, and that line is called the major axis. The minor axis is on the other direction. Right. And then as related to the graph, that will be easy. The equation of ellipse is either this or this. Now I ask you, what is the same thing and the difference between them? Well, we still have x squared over something, y squared over something. The difference is that a and b between the x or y. Right? If we want to graph it, it will be very simple. We have the 8 under the x, so we go 8 up, a down, and b to the left, b to the right. The difference here is that out of all of this, a is going to be the biggest one. So a is bigger than b, a is bigger than c. And whatever the bigger number at x or y, we're going to have the vertical or horizontal ellipse. Right? Once again, the form is x squared divided by something plus y squared divided by something equal to 1. Whatever bigger number under the x is going to be horizontal, under the y is going to be vertical. And then we draw the box and then we graph. The graph actually is very easy, but the a will give us a is equal to the distance from the center to the vertex, to each of the vertex, and then b is the distance from center to the minor axis. Right, the minor axis is perpendicular to the major axis, so distance on minor axis. And then c is equal to the distance from the center to each of the focus. So c is the distance from the center to the focus, and the center to the vertex is going to be a, which is the distance on the minor axis. And finally, we have the Pythagorean theorem. Since a is the biggest one, it stands by itself. We have b squared plus c squared equal to a squared. Right, so those are the characteristics of an ellipse. One center in the middle. From the center to the focus, to a focus, is c. From the center to the vertex is a. From the center to the minor axis is going to be b. And the relation is b squared plus c squared equal to a squared. Right, now let's look at there is a sample. Find the equation of ellipse with center at the origin. So we know the center origin. So it's either one of those forms. The focus is at 2 and 0, and the vertex is at 4 and 0. First, center at the origin, right? Now, one focus is at 2 and 0. X equal to 2, y equal to 0. So that is one focus. By the way, center is the center of symmetry. Sort of, there will be another focus on the opposite side. And the distance from the center to the focus is going to be 2. So the distance from the center to the focus is going to be 2, and that is C. Next, the vertex, one of them is 4 and 0. Of course, the center, so there will be another point across from it. So the distance from the center to the vertex is equal to 4, and that is A. And the rest is easy. We have the equation B squared plus C squared equal to A squared. So we can solve for B from here, right? A squared is 4 squared minus C squared, so it's 12. So B is square root of 12, which is square root of 3 and square root of 4. That is B. So what is 2 square root of 4? 2 square root of 3. So it's about 3.46. So that is B is about 3.46. Right. So for the ellipse, we just need to determine A, B, and C. And when we know the vertex, and when we know the focus, that will be easy. Meaning from the center, go to the vertex, horizontal. So B is going to be vertical, 3.46. So we're going to have this distance is going to be B. So we go up and down B unit. And left and right 4 unit or A unit. And I can draw a box there. And the ellipse is going to go around like that. Because I can draw better that, but right, so need to know A, B, and C pretty much. A is the distance from the center to the vertex, and C is the distance from the center to the focus. B is the distances on the minor axis, and we have the minor axis, the major axis. Draw a box. The ellipse will fit inside that box. Right. Oh, we want the equation, right? The equation is even easier. X squared over something square plus y squared over something square equal to 1. And now we have the horizontal ellipse, so we go 4 to the left, 4 to the right. Left and right is 4, so 4 square here. And up and down 2 square root of 3 or square root of 12, so we have square root of 12. square. So we go 4 left and 4 right. So 4 square at the bottom below the x square. And square root of 12 up and down. So square root of 12 at the bottom square. So it's going to be 12 equal to 1. Oh, simple enough. Now, analyze and graph the ellipse. This should be easy, right? So x square, y square. Under the x square there's 25, meaning that we're going to go left and right 5 units. Left and right 5 units. 16, so 5 plus or minus 5. So up, I mean left or right. Left and right. The 16, we have plus or minus 4, up and down. So we draw the box. So always have the box first. This one, when we have x1 y square, it is not x minus h square and x minus k square, meaning there's nothing there, no h and k, so there is no transformation. The center will be right at the origin. Ellipse will fit inside this. Now, the bigger number is under the x. So that's going to be horizontal. So we'll go 5 left and 5 right. So we have 2 vertices. Plus or minus 5, comma 0. Because of that, the focus have to be in between here as well. I mean on the x-axis. But 4 up and 4 down, so meaning b is equal to 4. And the distance from the vertex to the center is 5, which is a. So if a, we have b is 4, and we can find c. So b square plus c square is equal to a square. So c square is equal to 25 square minus 16 square is 9. So c is equal to 3. With that, of course, we go 3 units to the left and 3 units to the right to have 2 foci. So we have the vertices as 5, 0, negative 5, 0. The foci will be plus or minus 3, comma 0. And then the center, of course, 0, 0. And then the horizontal ellipse, that's what we have. Right. Next, graph and analyze 16x squared and y squared. I think there's a typo there, obviously. (16x squared, y squared). We have to turn into the equation where the right hand side is equal to 1. So this is easy enough. Just divide by 16 on both sides. The reason we divide by 16, so we have 1 on the right hand side. 16 cancel out. We have x squared over 1 square and y squared over 16. Right, now on the x is 1, meaning that we're going to go plus or minus 1, meaning left and right. The 16 plus or minus 4 up and down. Now, so actually there we have the graph already. 4 up, 4 down, 1 left, 1 right. So we have the box. And the ellipse, of course, inside that box. So that's the ellipse. The bigger numbers is below the y, so that's why it's vertical. And that, of course, the 4 is going to also the distance from the center. Distance from the center to the vertex, to the vertices, 2 of them, 4 unit up and 4 unit down. Right? So it's easy to graph it from the equation. 4 up and down, 1 left and right. Have the box, the ellipse inside that box. The distance from the center to the vertex is going to be 4. So that is A. Distance from the center to the vertex is 4, which is A. 1 is the other distance on the perpendicular to the major axis. So B is going to be equal to 1. We have B, we have A. Suddenly we can find C. I mean the distance C, that is. So B square plus C square equal to A square. So C square is equal to A square minus B square, A square minus B square. So that is 4 square, 16 minus 1, that's 15. So C is equal to square root of 15. Meaning that from the center we go square root of 15 up and square root of 15 down. We have 2 foci. That's the ellipse, right? So here we can get the coordinate of the vertex. 4 up, 4 down from the origin. So x equal to 0, y could be 4, could be negative 4. And then 2 foci, square root of 15 up or square root of 15 down from the center. So we have the vertices, the foci, and the center. And then of course the major axis, minor axis, raw the box equation. So simple enough. So in the ellipse, center in the middle, 2 foci, 2 vertices, all of them on the same line, and that line contains the major axis. The minor axis is perpendicular to it, will give us the distance B. Right. Now, if we have the center H and K, so just like what we have in the ellipse earlier, in the parabola earlier, we just translate H unit to the right and K unit to the right, and we have all of that. It's always relate the graph, the equation, and the characteristic of that conic section. In this case, is the ellipse. So we need to know the center, vertex, center, vertices, and foci. Our A, B, C, we need to know 2 of them, and to find the other. Okay, of course the equation is here. Right, next, find the equation of ellipse center is -1 and 2. So as always associate the graph, the characteristic of the conic section, and the equation. So that's why all of them I always have the graph next to it. The center is -1, x equal to -1, y equal to 2. X equal to -1, y equal to 2. And one focus is x equal to -3. One focus, x equal to -3, y equal to 1. Because symmetric, if one focus is there, there will be another focus on the other side. Of course, we will write the coordinate for them later. And then one vertex is -5 and 2. -5 and 2. Of course, with that we know the major axis had to be horizontal, because the major axis contains everything. One center in the middle, 2 foci, 2 vertices. And then the other direction will give us the minor axis. Right, so first, what do we have? From the center to the focus, that distance is c, and when we put on the graph -1 and 2, the center from -3 and 2 are focused, that distance is 2. And the distance from the center to a vertex, that is a, and from the center to the vertex, from -1, 2 to -5, 2, it's going to be 4. And this one we know center is -1 and 2. Right. We have A, we have C. Let's just find B. Will be the distance on the minor axis. A is the biggest number, so it will stand by itself. So we can find B. A square minus C square. 16 minus 4 is 12. So B square is 12. So B is square root of 12. We did earlier 2 square root of 3, or about 3.46. Right, so that means we go 3.46. 1, 2, 3 up, and 3.46 down. 1, 2, 3, and we have the box. Oops. Right, and the ellipse will be inside this box. Right, the equation x squared over something square plus y squared, this one we have the center, so the equation will be x minus something square y minus something square equal to 1 over something square. And since we go left and right 4 units, so it's going to be 4 square left and right, and 2 square root of 3 up and down, so square root of 12 square. Right, so left and right 4 units, so that's why we put 4 square below the x square. Left and right square root of 12, so we go up and down square root of 12. Right, and then where the center -1, we go with x, and 2 go with y, and simplify this equation. We have x plus 1 square over 16 plus y minus 2 square over 12 equal to 1. Right, so always relate between the characteristic of the conic equation and the graph. So By the way, we have a center there. If we want to write the characteristic, the foci will be at -1 and 2. That is the center, but we go left and right 2 units. That gives us the foci. Of course, -3 and 1. It's 3 and 2, sorry. And -3 and 1 and 2. That gives us the foci. -1, 2 units to the left and 2 units to the right. 2 units to the left give us -3 and 2. 2 units to the right, 1 and 2. So that gives us the foci. The vertices based from the center, we go a unit left and a unit right, so plus or minus 4. Meaning that we have the point -5 and 2 and 3 and 2. Yeah. So of course we can go to the equation. That equation. But I said we don't need to. From the center to the vertex, that distance is a. Okay, a to left, a to right, or up or down. And then from the center to the focus, left, right, or up, down, it's going to be c. And so that's what we have in this case. Next, analyze the equation and then graph. Right. So this just like what we have earlier. We have to do the completion square first before we can do anything. So analyze. So I keep the x square with the x, and then the y square with the y. The numbers, let's just move to the other side. So I try to turn this into a 2 square, turn that into this form. Right, to do that, let's factor out the 9. X square. Factor out the 9, right? So that should be 2. Right. We will need to add something here to make a perfect square. And then here we have y square minus 4y. Again, we're going to add something too to make a square. On the other side is -4, and we're going to add something to balance this, and add something to balance that. Right. What we need to add is going to be half of that number, and then square. Half of that number is square. 1 square is 1. Since we add 1 on this side, but we have to multiply by 9 as well. So 1 times 9 is 9. So I'm going to add 9 on the other side. Next, half of this number, and then square. Half of that number is -2. Square is going to be 4. Right, so that's what we have. When we make a perfect square, by the way, this is +1, so x, that's just y. -4 plus 4 is 0 plus 9, so it's 9. So that is the equation. So divide by 9. On both sides we have x plus 1 square because we need the right hand side to be 1, so we divide by 9. So we have x squared plus 1 square over 1 square, y minus 2 square over 3 square equal to 1. So we have the center as -1 and 2. X equal to -1, y equal to 2. And then if we just want the graph, it's easy. One unit left and right. If we don't need to find the focus, the foci or the vertices, the graph will be easy. 1 left and 1 right, 3 up and 3 down. And then the ellipse will be inside this box. Right, first of all, the center. H equal to -1, case is equal to 2 from the equation. Right, now we go 3 up and down. That is the furthest distance, so it's going to be A is going to be 3. And the other one is going to be B. So we have A, we have B. So with that, we can find the vertices from the center. Notice that this is the vertical ellipse, so go up and down. A unit. So just plus or minus 3. So the vertices, the coordinate is x equal to -1, y equal to 5, and x equal to -1, y equal to -1. So those are 2 vertices. And then to find 2 foci, we have B and A, we can find C. So C square is equal to A square minus B square. So that is 8. So C is 2 square root of 2. I mean square root of A is 2 square root of 2. And we have C. So we can write the 2 foci based from the center. C is 2 square root of 2. Notice that the foci, vertices, and center all from on the same line. So this is vertical. So I'm going to add to the y-axis. So, like I said, don't have to memorize the formula in this table. Don't need to know that. Need to know the center though. And from the center, if this is the vertical, we're going to add to the y component. If it's horizontal, we're going to add to the x component of the center. We use C, the distance from the center to the focus, and we use A, the distance from the center to the vertex, and we just add. So A3, so just add and subtract that from the center, the y component of the center, and the foci add and subtract the b to the y component. Right. Try to do this problem without relying on the formula, and always link between the equation, the graph, and the characteristic. In this case, the characteristic of ellipse have a center in the middle, two foci, and two vertices, all of them on the major axis. The minor axis is the perpendicular to that. And one properties of the ellipse that I forgot to mention in this is whenever we have an ellipse. Let me see. Okay. Right, let's say when we have an ellipse, this is the major axis. There will be two foci, say two foci here. A property of an ellipse is that if you go from one focus when it's right elliptical surface, it will go to the other focus. So if think about the game of pool, if the pool table is in the ellipse, you put one ball here, and there's the hole. All we need to do is just when you hit that ball to the elliptical wall, it will reflect, go to the hole to the other side. So, so we can build, use this to build a stadium. For example, if we want to focus, think about this. If it is a stadium elliptical form like this, one guy stand on this side, even though he whisper, it will reflect to the side and then go to the other guy on the other focus. So if we want to build a stadium, or we want to build a theater, the center stage will be here. Whenever that guy sing, it will hit the wall and go to the other focus. So the other guy sitting on the other focus is having the best seat in the house. Right. So with that, I stop section 9.3 here. As always, thank you for watching, and see you in another video in pre-calculus.